The title of this video says China just replaced aluminum. That sounds dramatic, maybe even a little crazy, but by the time this video is over, you are going to understand exactly why we said it. And you are going to agree. Because what Xiaomi just did to the way cars are built does not just improve on the old process. It makes the old process look like something from a different century, which it is. Picture this. It is January 2021. Xiaomi, the Chinese electronics company that built its empire on $30 earbuds and budget smartphones, gets placed on a United States government sanctions list, the kind that cuts you off from American investors. At an emergency board meeting, someone asks the question out loud. If the phone business gets shut down, what happens to 30,000 employees? That question does not lead to panic. It leads to a decision. 3 months later, on March 30th, 2021, Xiaomi files with the Hong Kong Stock Exchange. They are going to build a car, not a concept, not a partnership with an existing automaker, a real car designed and engineered from scratch. Lei Jun, the company's founder, calls it publicly what it is: the last major entrepreneurial project of his life. Every traditional automaker on the planet has the same reaction. Who are these people? They make phones. They have never built a car, never certified a vehicle for public roads, never operated a factory that does anything more mechanically complex than assembling a screen. They have no crash test history, no safety engineers, no dealer network, no 30 years of suspension tuning accumulated across a dozen model lines. The room laughs. 3 years later, nobody is laughing. On April 1st, 2025, professional racing driver Vincent Radermecker drove the Xiaomi SU7 Ultra around the Nürburgring Nordschleife in 7 minutes and 4.957 seconds. That lap was certified by TÜV Rheinland and a notary. It made the SU7 Ultra the fastest production electric sedan in the history of that circuit. It beat the Porsche Taycan Turbo GT. It beat the Rimac Nevera. On the same day, Xiaomi's own test driver Ren Zhoucan put the prototype version of the same car around the same track in 6 minutes and 22 seconds, making it the third fastest car to ever officially lap the Nurburgring, behind only 2 purpose-built racing prototypes. The craziest part is not the speed. The craziest part is what they built to get there. Xiaomi did not improve on existing automotive technology. They threw it out. No traditional welding. No stamping hundreds of steel pieces together. No giant baking ovens. They used artificial intelligence to find an alloy formula that had never been tested before, built a casting machine the size of 2 basketball courts to shape it, and turned the battery itself into the structural skeleton of the car. Every claim in this video is backed by machines already running in Beijing right now. Let's start at the beginning. The problem that has never been solved. The way cars are built today is identical to how they were built in the 1950s. You stamp flat sheets of metal into shapes. You weld those shapes together. Hundreds of pieces, thousands of welds. Same process every generation. Think about what that actually means. Every weld in a car chassis is a structural compromise. The metal on either side of that weld has been heated to the point of melting, then cooled again. That heat-affected zone is weaker than the base metal around it. It vibrates differently. It fatigues differently. A standard car body can have hundreds of individual stamped parts held together by 1,000 or more welds. Each one adds weight. Each one is a potential starting point for noise, vibration, or long-term failure. Engineers have spent 70 years shaving grams here and there. The architecture underneath never changed. Then EVs came along and made the whole situation worse. A large electric vehicle battery is heavy, not slightly heavy, substantially heavy. The 93.7 kilowatt-hour pack in the Xiaomi SU7 Ultra carries serious mass. And in almost every EV on the road today, that battery does exactly one thing: stores electricity. It bolts under the floor like a suitcase, which makes the car heavier, which requires a stronger chassis, which requires more battery to move the extra chassis weight, which makes the car heavier still. The spiral has no natural floor. Engineers hate it. Customers pay for it in every range estimate that falls short. Tesla round, it distorts the part. When a large, complex aluminum casting heats to those temperatures, it moves. Fractions of a millimeter in some places, more in others. And in automotive manufacturing, fractions of a millimeter matter enormously. A suspension pickup point shifted by half a millimeter changes the handling geometry of the entire car. A firewall that warps even slightly misaligns every component bolted to it. Every major automaker investigated this. BMW, Volkswagen, Ford, General Motors. Some spent years on it. The problem does not yield to venting systems, precision tooling, or staged cooling. It is a property of the physics of large aluminum castings under heat. The conclusion, every time, from every team, was the same. The right alloy does not exist. The industry stopped trying and called it a physical constraint. Most moved on. Xiaomi refused to move on. The AI that invented a new metal. In 2022, Xiaomi's materials engineering team built a deep learning simulation platform they called the Material Genome. The reference is deliberate. The Human Genome Project mapped every base pair of human DNA. The Material Genome platform was built to map the possibility space of aluminum alloy chemistry, to find the combination that no human had found yet. Think of what that space looks like. An aluminum alloy is defined by ratios of its constituent elements: aluminum, silicon, magnesium, cerium, lanthanum, copper, zinc, and others. Each element at each concentration level changes how the final material behaves, how strong it is, how much it can flex before fracturing, how its grains form as it cools. The number of meaningfully distinct combinations is in the hundreds of millions. The Material Genome platform ran simulations across more than 10 million distinct formulas. Here is what that number means. If a human metallurgist tested one formula every single working day without a single day off, it would take 27,000 years to cover the same ground. The AI covered it in months. Think of it this way. Imagine trying to find the perfect chocolate chip cookie recipe. But instead of testing 10 or 20 recipes over a few weekends, you run 10 million simultaneous simulations, accounting for every possible variation in ingredients, temperature, and timing. And the program identifies the exact formula that produces perfection before you ever turn on the oven. That is what Xiaomi did. Except instead of cookies, it was the molecular architecture of a previously unknown metal. The platform found a formula. The lab synthesized it. It hit every target. They called it Titan's metal, an 11-element aluminum alloy patented by Xiaomi in August 2023. When it cools after being cast, it comes out strong, precise, and assembly ready. No oven, no 8-hour bake, no distortion, no compromise. In practical terms, Xiaomi's manufacturing line moves faster, wastes less energy, and produces parts that fit together better because the tolerances are tighter. One thing worth saying clearly, because the internet proprietary alloy, what they replaced is the heat treatment requirement. The rare earth additions in the formula act as grain refiners during solidification, promoting a uniform internal structure without any external heat input. The casting exits the mold exactly as designed. That is what was blocking everyone else. Not the aluminum, the oven. Now, you need a machine large enough to use it, the machine that prints car chassis. Tesla's 9,000-ton Giga press was described by the Automotive press when it was revealed as the limit of what manufacturing technology could achieve. The kind of machine that makes experienced engineers go quiet when they walk into the same building. Xiaomi built a 9,100-ton version and called it the HyperCasting Machine. The cluster covers 840 square meters, 2 full-size basketball courts, side by side. It weighs 1,050 tons. It heats Titan's metal to 700 degrees Celsius and injects a 90-kilogram charge of molten alloy into the mold cavity in 100 milliseconds. At that injection speed, air has no time to form bubbles inside the metal. Air bubbles in cast metal are invisible structural failures waiting to happen. Under extreme load, they become fracture points. By injecting faster than bubbles can form, Xiaomi produces parts with aerospace-grade internal density. Here is what that machine actually does in production. The rear underbody of a conventional car, one of the most structurally loaded sections of the entire vehicle, is assembled from 72 individually stamped steel components, held together by 840 separate weld joints. Every component manufactured, shipped, stored, retrieved, positioned, clamped, and welded one at a time. Several hours of work per vehicle. Xiaomi's HyperCasting machine produces the equivalent section as a single piece in 100 seconds. 72 parts become one. 840 welds become zero. Production time drops by 45%. The cast section is 17% lighter than the stamped steel alternative. Cabin road noise drops by 2 decibels, a 37% reduction in perceived intensity because the decibel scale is logarithmic, and there are no weld joint vibration discontinuities left to resonate. Every casting is AI inspected in under 2 seconds before leaving the machine. Anything outside tolerance by more than 0.05 of a millimeter is automatically rejected. At full production capacity, one complete car rolls off the Yizhuang line every 76 seconds. And the factory has more than 700 robots making it happen. Now, here is where the story gets genuinely wild. The battery that became the bones. In almost every electric vehicle on the road today, the battery is an expensive, heavy box bolted underneath the floor. It does exactly one thing. It stores electricity. It contributes zero structural value. It is dead weight that happens to be energized. Xiaomi asked the question nobody else had asked at this scale. What if the battery was not a passenger? What if it was the actual skeleton of the car? This is CTB technology, cell to body. The individual prismatic battery cells are built directly into the structural underbody of the car. The top surface of the battery module is the cabin floor. The cells are not only storing energy, they are carrying loads, compression, shear, and bending, simultaneously. Then, Xiaomi did something that sounds backwards, but is one of the cleverest engineering decisions in this entire story. They flipped every battery cell upside down. Every lithium-ion cell has a pressure relief valve, a designed weak toward passengers. Engineers have to install thick protective material between those valves and the cabin floor. Necessary, but heavy and tall. When Xiaomi inverted every cell, the valves now face downward, toward the road. The floor above the cells no longer needs to be a thermal protection layer. It just carries mechanical load, which it is already doing. This one geometric reversal allowed Xiaomi to remove roughly 40 millimeters of protective material from the pack assembly. The total battery plus floor thickness dropped to 120 millimeters, the spine of a hardcover book. That 40 millimeters changes everything downstream. The car sits lower than most dedicated sports cars. The center of gravity drops below a Porsche 911 Carrera, a car that has treated low center of gravity as its primary design mandate for 60 years. In a corner, less weight transfers between tires. More grip is available. The handling balance is flatter and faster at every speed. And because the cells are structural members, the whole underbody becomes extraordinarily stiff. How stiff? Torsional stiffness of 51,000 Newton meters per degree. To give that number a reference that actually lands, a Ford F-150 Raptor, one of the most structurally engineered trucks ever built, measures around 25,000 Newton meters per degree. The Xiaomi sedan is twice as stiff as a trophy truck. Twice. That is not a marginal gain. That is a different category of structure entirely. When a chassis does not flex, every system attached to it works better. Suspension geometry holds precisely as tuned. Tires stay flat through cornering. Steering communicates accurately. The engineers designed for all of that, and they designed it to carry 1,527 horsepower from 3 electric motors. 0 to 100 kilometers per hour in 1.97 seconds. Top speed of 350 kilometers per hour. The V8's motor, fully self-developed by Xiaomi, spins at 27,200 RPM. Xiaomi claims this is a world record for a production electric motor, and they have already surpassed it within their own lineup, with the V8S Evo motor running at 28,000 RPM in the new YU7 GT. Without the Titan's metal chassis, without the CTB battery skeleton, That rotational speed would destroy a conventional car structure through accumulated microfatigue alone. Every part of this system was designed to work with every other part, not assembled from separate engineering decisions, designed as one integrated solution from the beginning. What this actually changes: Xiaomi proved that a company with no automotive history, starting from a blank sheet, can out-engineer teams that have been working on the same problems for decades. Not because they had more engineers, because they asked different questions. Using AI to search 10 million alloy formulas instead of iterating on existing ones. Building a casting machine and a proprietary alloy together so each is designed for the other. Turning the battery from passenger to skeleton, then flipping every cell to unlock 40 more millimeters of height. That is what first principles engineering looks like when there is nothing to protect and everything to prove. The Titan's metal is running. The HyperCasting machines are operating around the clock. The CTB architecture is already in customer hands. In 2025, Xiaomi delivered over 400,000 vehicles. This month, the U7 GT set a new official Nürburgring SUV lap record. And Western automakers who have now torn down the SU7 Ultra and studied every section have not announced a single equivalent program. Xiaomi owns the patent. Xiaomi has the production data. That gap does not close quickly. The era of assembling car bodies from hundreds of stamped steel pieces, welding them together with thousands of individual joints, and strapping the battery underneath like an afterthought is not ending in some future decade. It is ending right now. Not slowly, not gradually, overnight. And the traditional automotive world knows it. If you made it this far, you clearly love this stuff as much as we do. Hit the like button and subscribe if you have not already so you do not miss what is coming next. We are going deep on more engineering stories that are reshaping the world, because the next few years are going to move incredibly fast. Now here's the question we want you to answer in the comments. Do you think another tech company like Apple, Samsung, or Google could do exactly what Xiaomi just did and build a car from scratch that actually competes at the highest level? Drop your answer below and let's talk about it.